Hi class, how are you today? Well, that's not a very rational response. The learning target for today is to simplify square roots and rationalize the denominator. So two separate things that are very much connected. For your scale, for a 3, you can simplify square roots and rationalize the denominator. 2, you can simplify square roots or rationalize the denominator, but not both. 1, you can partially do one of these, but your answers are often not fully simplified. So you'll simplify it a little bit, or you'll do some of the rationalization, but not simplify it all the way. And 0, you cannot simplify square roots or rationalize the denominator. Let's get started. All right, before we start with simplifying square roots, we're going to need to use the perfect squares. So, in case you don't know your perfect squares, here's a list. So, perfect squares are numbers that are a result of a number being squared, or a number multiplying by itself. So, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6, all the way up to 22 times 22. So, obviously there are infinitely many squares because you can go up to any number and then square it. I put the first 22. Now, we start off with the first problem, square root of 20. So if we have the square root of 20, we want to simplify that. The way you simplify it is you think of the factors of 20. What is a perfect square that you can divide out of 20, or is a factor of 20? So, always good to go down the list. Ignore 1 because 1 works for every single number. So, you don't have to take 1 out. So, we start with 4. 20 divided by 4 is 5. That works. So, all we have to do is say we take out 4, still under the square root, so square root of 4. And what is left over when we take out the square root of 4? When we divide 20 by 4? Well, 20 divided by 4 is 5. So we've got square root of 4 times the square root of 5. Then you take the perfect square and take the square root of it. What's the square root of 4? 2. And the square root of 5 you can't take the square root of nicely, so that stays square root of 5. So 2 times the square root of 5, or as many people say, 2 square roots of 5. Now let's look at the next problem, square root of 32. So once again, we look, ignore 1, can 4 divide 32? 32 divided by 4 is 8. So yes, that works. So notice there are two ways to do this. Let's do this way first, and then I'll show you a different way to do it. So you take out the square root of 4, then 32 divided by 4 is 8. So we've got the square root of 4 times the square root of 8. Then take the square root of 4, which is 2, times the square root of 8. Now you have to look. Is there a perfect square inside of 8? So again, 4. 8 divided by 4 is 2, so that works. So here's what you do. 2 times the square root of 4 times 8 divided by 4 is 2. So 2 times the square root of 4 times the square root of 2. So that leaves us with 2. The square root of 4 is 2. And times the square root of 2. Now we multiply these two. 2 times 2 is 4. And we're left with the square root of 2. So 4 square roots of 2. Let me just circle the answers. Now, like I said, there's another way you can do this. So you look through, 4 works. 4 is a perfect square you can take out of 32. However, there might be a bigger one. 9, no, that doesn't work. 32 doesn't divide by 9. 9 isn't a factor of 32. 16, though. 32 divided by 16 is 2. That works. So you get square root of 16 times 32 divided by 16 is 2. So the square root of 2. And the square root of 16 is 4. So 4 square roots of 2. So either way, you'll get the same answer. This way might be a little bit quicker, but it involves you trying out a whole bunch of different numbers. All right, let's do one more example. 2 times the square root of 75. So the 2 is going to stay there. Just like when we reduce this up here, same thing, the 2 stays right there. And we're going to multiply that by whatever perfect square we take out. So, square root of 75, we have to think of what perfect squares can we take out of 75. So, looking through, 4 doesn't work, 9 doesn't work, 16 doesn't work, 25. 75 divided by 25 is 3. So we say 2 times the square root of 25 times the square root of 3. Then 2 times square root of 25 is 5 times the square root of 3. So 10 square roots of 3. All right, so that's all you do for simplifying. All you have to do is find the perfect square that you can divide out, then take the square root of that number, multiplying it by whatever it divides by, and whatever the square of that number is times the square root. Now let's go to rationalizing the denominator. Okay. So when you're dividing square roots, when you have a square root in the denominator, you're not allowed to have the square root stay in the denominator. You need to be able to do something to get rid of the square root in the denominator. So one way you could go about that is trying to reduce. And if you can reduce, you should always try to reduce first. However, 3 and 5, you can't reduce those at all. There's no number that goes into both 3 and 5 except 1, and that wouldn't do anything. So there's another method you can use, multiplying by 1. Well, you think multiplying by 1 won't change anything, right? You're just multiplying by 1. It'll keep it exactly the same. Yes. But if you multiply by a fraction that is the same thing on the top and the bottom, you're effectively multiplying by 1, but changing some things around. So let's multiply the top and the bottom by the denominator. So let's multiply by the square root of 5 over the square root of 5. So we're multiplying by 1. Square root of 5 divided by the square root of 5 is just 1. Anything divided by itself is 1. However, now if we multiply here, square root of 3 times square root of 5 is the square root of 15. And square root of 5 times square root of 5 is the square root of 25. Square root of 15 doesn't have any perfect squares. You can simplify out of it, so that stays exactly the same. And then the square root of 25 is 5. Now, you can actually skip this step right here, because whenever you multiply a square root by itself, square root of 5 times the square root of 5 is just the square root of 5 squared, which is 5. Whenever you multiply a square root by itself, it's just the number underneath. Always will be that case. And you can't simplify that anymore. The square root of 15 and 5 cannot simplify anymore. 1 is the square root, 1 is not. So they can't simplify, they can't reduce. This is your answer. What if we have square root of 8 over the square root of 2? Like I said in the first one, if you can reduce, do it. So square root of 8 over the square root of 2, well, 8 divided by 2 is 4, and we can reduce because they're both in the square root. They both are under a square root, so you can reduce them. So 8 divided by 2 is 4. So divide them both by 2. 8 divided by 2 is 4, so the square root of 4, still under the square root. And 2 divided by 2 is 1, so square root of 1. And now, well, the square root of 4 is 2, the square root of 1 is 1, and 2 divided by 1 is 2. And that's it. So you don't always have to multiply the top and the bottom by the square root. You will in probably a lot of cases, but in some cases you don't, and it's a lot quicker if you don't. So you could actually do this, and sometimes it's just easier to just always multiply by the square root in the denominator. It's easier to remember. You just do the same thing every time. But in the long run, it is actually easier if you can reduce first. So always reduce first if you can, then from there multiply the top and the bottom by the square root in the denominator. Next, we have square root of 6 over the square root of 10. Well, that can be reduced. 6 and 10 can both be divided by 2. 6 divided by 2 is 3, so square root of 3, and 10 divided by 2 is 5, so square root of 5. Now those can't simplify anymore, as we saw up above. And now we've actually got that same case again. So now we're just going to do what we did before. Square root of 5 over the square root of 5, multiply the top and the bottom, and that will give you the square root of 15 over the square root of 25, and so square root of 15 over 5. And again, can't simplify any more than that. All right, for this last example, 2 and 3 can't reduce, 7 and 11 can't reduce, and you can't go within other ones because you can only look at the numbers that are by themselves or the numbers under the square root. You can't mix and match those. So we need to multiply the top and the bottom by the denominator, but just the square root in the denominator. So only the square root of 11. Now you could multiply the top and the bottom by 3 square root of 11. It's still 1, but you would end up needing to reduce later, and it's actually more difficult if you do it that way. So let's just multiply the top and the bottom by the square root of 11. So you're multiplying by the square root of 11, no whole numbers, no regular numbers. So 2 just stays there. 2 doesn't multiply by anything. Under the square root, we've got 7 and 11. So we do multiply those. 7 times 11 is 77. So we've got the square root of 77 over 3, and then 11 times 11, square root of 121. So 2 square root of 77 over 3 times square root of 121 is 11. So the bottom no longer has the denominator, like we were trying to do. And then 2 square root of 77 on top still. And on bottom, 3 times 11 is 33. None of this can reduce anymore. Not even the 77 and 33, again, because one's under the square root and one is not. So this is as far as it can reduce. All right, now time for the sponge activity. I want you to simplify each expression fully, as much as you can. So number 1, I want you to simplify square root of 27. Number 2, simplify the square root of 800. Number 3, simplify the square root of 324. Number 4, I want you to simplify 2 divided by the square root of 3, so rationalize the denominator. Make sure there's no square root in the denominator. Number 5, square root of 18 over square root of 8. Number 6, 4 over the square root of 2. And number 7, square root of 2 over 3 square root of 3. So for those last 4, make sure that there are no square roots in the denominator, but also fully simplify it, fully reduce it. All right, that's it for this lesson. Once again, please make sure to take notes on the entire lesson, take a picture of everything, submit it all to Google Classroom, and have a good night.